Sorry, this is the wrong specimen paper. The one with 2022 specimen. That's this one. Acha, for 2022. Acha, let's try this one. Remember, you'll get the idea that the data booklet part, tables, etc., would be given or quoted with the question. So we're going to start with the first one. Okay, jo first. So the first one is, okay, the properties of elements and the compounds. One second, let me add people. So the first one is, that's 2022 specimen paper. This is using identify the elements that forms a soluble hydroxide and an insoluble sulfate. Okay, so this is group 2. Group 2 ke andar, remember this, okay, when you go down the group, the sulfates, they become insoluble, and when you move down the group, the hydroxides become soluble. So the answer to this one is, the first one is barium. TK, it's this one. Okay, bottom one, barium hydroxide is soluble, barium sulfate is insoluble. Here, identify the most volatile element in a group that contains elements in all 3 states of matter. So in all 3 states, you have group 17, and that's fluorine, that's a gas. Chlorine is also a gas. Br2 is a red-brown liquid, and iodine is a solid. So all 3 states. कौन होता है all 3 states में? That's अच्छा, साथ ही में notes भी एक second. Yeah, is it? अच्छा, one second. So खुल जाएगा यहाँ पे. अच्छा, all 3 states. So this is group 17. That's all 3 states. Which one is more volatile? The most volatile. The most volatile is the first one. You can remember this, down the group, the boiling point increases. So the most volatile is the first one. They all have van der Waals forces. So the first one has the least van der Waals forces. Agar wo reason पूछता ना तो the first one is going to have the least van der Waals forces. Then identify the element that forms the largest cation. So largest जो होगा bottom वाला होगा. It's this row. You can remember the bottom ones, they have the bigger shells. So largest one is the one that is at the bottom. He's talking about the cations. So cations are formed by metals. So in दोनों में से कोई होगा. It's going to be either cesium or barium. And the answer to this is going to be cesium. एक तो पहले largest जो है, that's the one at the bottom. Cation is going to be these two. This is going to be an anion. It's going to be a negative ion. अच्छा, इन दोनों में the largest would be cesium because remember कि अगर मैं वैसे दिखाऊं कि atomic radius decreases across the period. तो यहाँ पे कोई ना कोई एक image होगा. ठीक है, let's have a look at this one. So remember this, your atomic radius decreases to the right because you have more protons. Yani, for example, sodium over here has 11 protons. Chlorine on the other side has 17 protons. So ये वो उसका answer होगा. इसका largest cation would be this one. Next part, it's about ionization energy. How do you define the first ionization energy? First thing, it's पहला electron remove करना है atom में से. So it's the energy that is needed. Remember, it's always endothermic, so always needed to remove 1 mole of electrons from 1 mole of gaseous atoms. और फिर बनता क्या है? To form 1 mole of gaseous plus 1 ions. अच्छा, suggest why the first ionization energy of B is much less than that of A. तो यहाँ पे क्या हो रहा है? Why is there a huge decrease? तो ये कौन सा ग्राफ है? Successive elements है, 6 successive elements. if I just Google across the period, what happens to ionization energies across the period, तो ये large decrease कब आता है? This happens, console graph ज़्यादा बेहतर होगा, just a second. I mean, let's have a look at this one. So now, across the period, the trend is that the ionization energies, they increase. Lekin as soon as the next period approaches, the next period ki ionization energies, they would be lesser compared to the first one. Why? Because you're moving down the group. So you move across the period, then you move to the lower, the next period, which is lower down. It's got a bigger shell. So he's talking about this dip. Why is there a dip? Because that is a smaller atom. If you look at, I mean, let's assume that's neon and this one is sodium. I mean, so the big dip is, कि मैं दोनों को draw कर लेता हूँ. Where's the paper? So they didn't tell us what A and B was. I'm just going to take that neon and sodium. So what's going to happen is, okay, neon has 10 protons, so it has a total of 10 electrons. Oh, so that's your A. That's neon, and let's call this sodium B, or assume that it's sodium. तो वहां पे क्या होगा कि sodium has 11 protons, but it's got 11 electrons. So the main reason why it's a lot easier to remove electrons from sodium is that the electron is really far away and it's more shielded. That's the reason. Okay, down the group, why do the ionization energies decrease? So C-marker question is, you have to write a lot about this. So you're going to write that B is more shielded. ठीक है, or has more shells. And electron is removed from a shell, or electron is removed, or the electron removed is much further away. Distance. And every time, remember, from now on, always remember, both आपने state कर दिया, you've stated the facts, but you also have to state one statement at the end, that because of this, the attraction of the electron, so hence, attraction between electron and nucleus decreases. Make sure to always, this always carries 1 mark. Factors okay, and this thing over here right at the end carries 1 mark. So much further away, more shielded, easier to remove electrons. So add that the electron and the nucleus are less attracted in this case. So next one, you have atomic radius of the element and atomic number. What happens? I showed you the graph. What happens? I think right before that, we did. As right before this, atomic radius across the period, it decreases. So the question is why? I mean, we know it decreases, so the graph would kind of look like this. So again, it's a 3-mark question. You have to explain why is it decreasing? Okay, if I take sodium on the extreme left, it has 11 protons, so it has 11 electrons, right? And I have chlorine, which is 17 protons, and it's got a total of 17 electrons. The thing is, they both have the same shells. So you have the same number of shells. So the number of shells remain constant. But across the period, the protons are increasing. Or nuclear charge increases. So 17 protons are going to attract electrons in the 3 shells much more strongly. So which is why it's going to be a lot smaller. So across the period, protons increase, so hence there's more. Yakri statement per se, it carries 1 mark. So because of that, there's going to be more attraction between outer shell electrons and the nucleus. ठीक है, that's about across the period. ठीक है, ये सारा यहाँ पे inorganic chemistry में everything is explained in a lot more detail. ये वाले सारे मैंने शेयर किए हैं, ठीक है। ये atomic radius वाला ये part है। You've got more shells, more attraction for electrons, but you have the same number of shells. More protons, more attraction for electrons. Now, moving to the next question, you've got describe in simple terms the structure of carbon-16, carbon-60. Now, that is a fullerene. Okay, so it has a simple molecular, which basically means it's a covalent molecule. So it's a simple molecular lattice. So that is what C60 looks like. C60 is an allotrope of carbon, where it's a ball-like structure. That's what C60 looks like. It has the same exact arrangement as graphite. It's sp2 hybridized, except that graphite is in the form of sheets. This is in the form of a ball-like structure. It's like, I mean, if you like wrap graphite into a ball-like structure, that is what a fullerene is. But a fullerene is a simple molecule. It's not a giant structure. Uske jo number of carbon atoms hai, it's limited. Every fullerene has a certain number of carbon atoms. It's not a giant structure. And so that's about it for fullerene. Remember, fullerene is the same as, it's similar to graphite. It's same sp2 hybridized. Carbon is making 3 bonds. Each carbon atom is making 3 bonds. The fourth electron is delocalized, the same as graphite, except that it's a simple molecule, not a giant structure. Graphite ki jo sheet hoti hai, that's in, I mean, that has no limit. It could be a very big sheet, or it could. So you have this one. It sublimes at approximately 800 kelvins. Diamond also sublimes, but only above 3800 kelvins. So the boiling points, I mean, there's a huge difference between diamond and this C60. Explain why C60 and diamond sublime at such different temperatures. So first thing is, diamond ka kya masla hai? Diamond is a giant covalent structure with lots of strong covalent bonds, which require a lot of energy to be broken. So for diamond, it's easy. Why is it having such a high melting point or boiling point? It is because it's got a very giant covalent structure, and there's a 3-dimensional network of strong covalent bonds. क्या spelling होती है dimensional? अच्छा, so it's a 3-dimensional network of strong covalent bonds. So large amounts of energy needed to break it. So now this other one was a ball-like structure. It's a ball-like structure, and it's a simple molecular structure. मतलब यहाँ पे there's मतलब वही सारा चल रहा है, ठीक है? So it's a ball-like structure. Now, जो कि अभी show किया था, I showed you the. Now, in the case of fullerene, you have you have intermolecular forces and the weak van der Waals forces. It's a non-polar molecule because all of them are carbon atoms, so there is no polarity. So it's got weak van der Waals forces. So less energy needed to overcome them. So that's about it. Okay. So फिर अगला next one, you've got C60 forms hydrocarbons with similar chemical properties to those of alkenes. Okay. One such hydrocarbon is C60H18. Define what a hydrocarbon is. It's a compound or a molecule which contains hydrogen and carbon atoms only. So, bas ye hydrocarbon, that's it. 1 mark. Next one is this one is an alkene. State a test to indicate the presence of double bonds. Asan, how do you figure out the double bonds? It's bromination. You add beer to aqueous at room temperature and pressure in the dark. I mean, there should be no sunlight. And what will happen is that the red brown bromine is going to get decolorized, or orange bromine. It reacts with the double bond, so it's decolorized. State the observation. We basically यहाँ पे लिखना था, ठीक है? So state the observation. You're going to state the observation. Up next part is about, I think it's about moles. तो अच्छा प्लीज कोई ये कैलकुलेटर जवेया हानि एक्सेट्रा कैलकुलेटर साथ रख लेना. I don't have a calculator at the moment. This one is 0.114 grams of C60. Is placed in a 100 cm3 container of hydrogen gas at a temperature of 20 and a pressure of 1 × 10⁵. The container is heated to make C60 and hydrogen gas react. So this reaction happens and this is produced. And after the reaction, the container is allowed to cool to 20 degrees centigrade. The pressure decreases to this, and all of the C60 has reacted. So name the type of reaction that occurs. What is this reaction? This is an addition reaction. ठीक है, वो type पूछ रहे. Type में it's either addition, substitution, or elimination. This is things getting added up. Calculate the amount in moles of C60. तो वो निकालना है, तो वो तो निकल आएगा आराम से कि you've got mass divided by mr. अच्छा, when you answer questions on your paper, make sure कि show your working as clearly as possible. कि बता दो भी कि इतना टाइम नहीं लगता, बस थोड़ा सा टाइम लगता है. Just make sure you write this. That's mass divided by the mr of C60, which is 0.144 grams divided by 60. C60 is the fullerene. It has 60 carbon atoms, so that's 60 times 12. कोई मुझे बता दे इसका क्या आंसर आ रहा है. One second. So just double check. 0.0002 moles. So ठीक है. So first, one thing is clear. We've got 0.0002 moles of this. ठीक है, ये मैं आ गया. And then he says in the next part, calculate the amount in moles of hydrogen gas that react with C60. So that is going to be slightly tricky. Because hydrogen is a gas. ठीक है, focus on hydrogen gas. It's present in a 100 cm3 container at a temperature of 20 degrees centigrade and at a pressure of 1 × 10⁵ pascals. So what you can do is you can use PV ideal gas equation. You know the volume, you know the temperature, and you also know the pressure. So I'm going to use PV is equal to nRT to figure out the moles of hydrogen gas. So moles would be PV divided by RT. ठीक है, और डायरेक्ट जंप करके पेपर में ये ना लिखना शुरू कर देना. I mean, write the expression that you're trying to solve. ठीक है, so that in case if you make some silly mistakes, at least they'll look at your working, what you're doing. ठीक है. अच्छा, P into V, that's 1 × 10⁵ into V, that's 100 cm3. So 1 × 10⁵ pascals into 100 cm3, that should be in meter cube. So meter cube में cm3, that's 10⁻⁻⁶. ठीक है, तो 100 cm3, remember that कि 100 cm3 को ना, it should be in meter cube. PV's nRT is all about meter cubes. So or divide by RT. तो R जो है that's 8.31 और मेरे ख्याल से टेम्परेचर कितना था, 20 centigrade था. So it was 20 centigrade. So what you can do is you can आगे चले गए. That should be in Kelvin. So that's going to be 20 plus 273. So what are we getting? So this one is 0.00410. Achha, but these are not the moles of, I mean, they are the moles of H2, but they are the moles of H2 initially that are present in the container. Because we have to now look, ke, kya ye sare ke sare, are these the moles that are reacting? So if we go back, to usne kहा ke he allowed to cool to 20. He says that all the C60 has reacted. Okay. So he has said that all the C60 reacted. He never said that all of the hydrogen is reacting. So the problem now is we're not sure we're not, so calculate the amount in moles of hydrogen gas that react. तो वो हम कैसे निकालेंगे? वो हम निकालेंगे. The way we're going to figure this out is these are the initial moles that are added. So the container still has hydrogen gas because there's still pressure being exerted. There's only one gas in the expression. So after the reaction, we're going to use PV is equal to nRT. Once the reaction has happened, I'm going to figure out the moles of the leftover hydrogen gas. There's only one thing that's going to be left over in this reaction. That's going to be hydrogen gas. क्योंकि ये दोनों तो solid हैं, ठीक है? So I'm going to do the same thing, repeat. I'm going to figure out the second moles of hydrogen, which is, I'm going to use PV is equal to nRT again. अच्छा, इस केस में टेम्परेचर तो आई थिंक उसने वही लिया हुआ है. This is 20 plus 273, but the pressure has now decreased. पहले 1 into 10 power 5 था, but after the reaction the pressure is now 2.21 into 10 power 4. Container भी वही है, it's the same container. So the pressure of the gas has decreased. Basically ये हुआ है कि you had a container and it had a certain amount of H2 gas, so it was exerting a greater pressure, and then the reaction happened and some of the hydrogen gas got used up. तो आपका जो pressure है वो decrease हो गया, ठीक है? Container का volume भी वही रहा है, so 2.21 into 10 power 4. So the pressure is 2.21 into 10 power 4 into volume is the same, 100 into 10 power minus 6. तो ये second, ये before है या after है? अच्छा, 0.000907 907 moles. तो फिर amount in moles that reacted, how much reacted? शुरू में ये डाला था और बाद में ये. If you subtract the two, what do you get? So what do you get? What do you get for this? 0.0032 moles. ठीक है? So the amount in moles that you're getting is 0.0032 moles. इसलिए वो marks भी ज़्यादा थे. It was 3 marks because you had to do a bit more working. ठीक है? So you got 0.0032 moles. So we found the moles of H2 that is reacting. It's 0.0032 moles. इसका मैं वो देख लेता हूँ, MSP for the specimen paper, this one. ठीक है, we got the same thing, 0.0032 और वो पहला भी वही है. ठीक है. अच्छा, so moving on. अगला part क्या कह रहा है question का? The other part is, he's saying use your answer to calculate reduce the molecular formula of hydrocarbon. So we have to figure out what X is. अच्छा, so in the equation we figured out this thing. तो ये क्या ratio बन रहा है? That's 1:, I think. What is this ratio? Javaria क्या आ रहा है? This is, I mean, what's the ratio? How many carbon C60 is reacting with how many H2? Is it 1:16? Just a second. this is 1:16. So that means that 60 carbons, C60 reacts with, one of them reacts with 16 H2 gas molecules. So the value of X comes out to be 16. The value of X is 16. So wahan se I'll figure out the value of the formula, which would be 32 over here. ठीक है, 1:16 aa raha hai, so this is X stands for 16. So the formula would be C60 and H would be 2 into 16. और फिर we did figure out the molecular formula, so we're done with that. और फिर उसके बाद है कि you've got this other part of the question which states that silicon shows the same type of bonding and structure as diamond. Silicon reacts with magnesium to form Mg2Si. Mg2Si reacts with hydrochloric acid to form this, and as solution of magnesium, construct the equation. So Mg2Si reacts with hydrochloric acid, HCl. Would likha be a solid, so you can act and dilute, so that's aqueous. To form what? To form gaseous SiH4 plus a solution of magnesium chloride. So that's again MgCl2, and that's going to be aqueous. State the shape of the SiH4 molecule. That's tetrahedral. क्योंकि 4 bonds and no lone pairs. So that's going to be tetrahedral. And next one. Next one is calcium and its compounds have a large variety of applications. Calcium metal reacts with most acids. When it's placed in dilute sulfuric acid, reacts vigorously at first. Iska reaction kya hota hai when it's placed with H2SO4? It's going to form calcium sulfate, plus it's going to form H2 gas. फिर वो कह रहा है after a short time a layer of calcium sulfate forms on the calcium metal and the reaction stops. Some of the calcium metal and dilute sulfuric acid remains unreacted. Suggest an explanation for this. So वो ये कह रहा है कि calcium को ना, so this is calcium, उसको H2SO4 के अंदर ना you've added it. So the particles are all H2SO4. So the reaction stops after a short time क्योंकि a layer of calcium sulfate is formed. क्योंकि जैसे ही वो react करेंगे ना, and the calcium sulfate is going to be formed. If you know the solubility of the sulfates, calcium sulfate is not very soluble. So what will happen is जैसे calcium sulfate बनेगा तो calcium के ऊपर ना there's going to be a deposit of calcium sulfate that would, because it's not going to dissolve. तो वो calcium sulfate उसके ऊपर ही बनना शुरू हो जाएगा. It will form on the top surface, and as it forms on the top surface, the calcium will no longer be able to react with the H2SO4 because there's going to be a protective coating. So the explanation for this is that calcium sulfate is insoluble. It forms a protective layer over the calcium. Which prevents collisions. तो आपका जो बाहर H2SO4 पड़ा है, that's not going to be able to react with the calcium over here. So which prevents collisions between H2SO4 and calcium. So that's about it. उसके बाद है कि calcium ethane diode is formed when calcium reacts with ethane dioic acid, double carboxylic acid है. And he says calcium ethane diode contains one cation and one anion. State the full electronic configuration of the cation. Cation obviously positive ion calcium ही होगा, that's +2. So it's got 20 electrons, but it has lost 2 electrons. So 20 would be 1s2, 2s2, 2p6, 3s2, 3p6. Up here 4s2, that's 20. But since it's 2 plus, it's the 4s electrons, the outermost electrons are gone. Deduce the charge on the cation calcium, so it's obviously +2. Deduce the fully displayed formula of the ethane dioic ion. तो उसने कहा था कि it's a carboxylic acid. So what happens when a carboxylic acid forms an ion? वो जो end वाला acid का जो H है ना, that goes away because it is an acid. And it ends up forming this particular ion. यानी अगर आप कोई भी carboxylic acid उठाओगे ना, let's say ethanoic acid, same चीज होगी. It's going to ionize and it's going to form CH3CO -1 and H +1. So आखिरी जो H +1 है, that is going to go away. Moving to the next one, this calcium chloride is used as an alternative to sodium chlorate in jo bhi hai. Chlorate ion is formed when cold aqueous NaOH reacts with chlorine. Write an ionic equation for the reaction. State symbols are not required. So pehle to ye reaction, you have to memorize this reaction. It's a group 17 reaction. So if you refer to the notes, so ये cold NaOH के साथ और hot NaOH के साथ there's a specific reaction that has to be remembered, जिसमें एक में NaClO बनता है और एक में there is NaClO3. So if you go to group 17, so right over here, you've got two reactions, one with cold NaOH, that's NaCl, NaClO, and H2O, and one with hot NaOH, higher temperature, that forms NaCl, NaClO3, and H2O. In this case, he's talking about cold NaOH, and he's not even talking about the equation, he's talking about the ionic equation. So I'm going to write the ionic equation for this. Let's go a second. Acha. Yeah. Acha, so I'm going to write the ionic equation for this. पहले तो full equation लिख लेते हैं, उससे देख लेते हैं कि how do you make the ionic equation. It's NaOH plus Cl2, it's going to form NaCl, plus it's going to form NaClO plus H2O. Or yeah. Now the only spectator in this whole equation is sodium ions, because sodium ions पहले भी वैसे ही थे, बाद में भी they're still the same. So all you have to do is you just have to get rid of the sodium ions. Okay, so OH over here is -1, ClO over here is -1, Cl over here is -1. So it's basically 2OH -1 plus Cl2, and it forms a Cl -1 plus ClO -1 plus H2O. So that's your ionic equation. Then he says that chlorate 1 ion is unstable and decomposes when heated. So it's decomposing. So he's saying it's a disproportionation reaction. What is meant by the disproportionation reaction? Ek mark. So same element gets oxidized and reduced. So the same element is getting oxidized and reduced. Cl over here is +1. मतलब calculate कर लो, its oxygen is -2, Cl would be +1, तब जाके you'll get -1. Cl over here is -1 and Cl over here is +5. क्योंकि oxygen is -6, 3 oxygens. So this must be +5, तब जाके -1 आएगा. Now anyways, we figured out it's a disproportionation reaction because it's getting reduced as well as getting oxidized. फिर reduce the oxidation number, वो अभी हमने कर लिया वैसे, वही किया हमने. Okay, so we did this part. Next one is now about redox. Redox कह रहा हूँ, ये organic है. Calcium reacts with 2-hydroxypropanoic acid to form product Y. This one. Identify the two other products. So he's talking about calcium carbonate. Or ये क्या? This is a carboxylic acid. So what happens when an acid reacts with a carbonate? It produces salt, which they've already said that's getting produced, and it's going to produce water and carbon dioxide. So these are the two other products that are going to be formed. फिर ये कोई reaction है, two possible methods of making 2-hydroxypropanoic acid are shown. So जब ये बना रहे उससे बस इंसानों की डिटेल पूछी होगी. What is reaction number 1? For this I'll just open the chart. Okay, where's the revision chart? ठीक है. अच्छा, starting कहाँ है हमारा? अच्छा, ये वाला, ये the market scheme. This one. Starting with the first one, it's a ketone, and this is a cyanohydrin. So क्या होता था ketone से cyanohydrin? That's this part. If you look at the chart, so you had a ketone, and it would turn into a cyanohydrin. What was a cyanohydrin? Cyano, इसका वो mechanism भी आना चाहिए, nucleophilic addition. Okay, the double bond O, either नीचे इसके mechanism भी दिया हुआ होगा. This one, the double bond O, ketone or aldehyde, it could happen for both. It could happen to any carbonyl compound. The Cn-1 will attack the carbon which was positive and bond with it, and वो जो ऊपर O-1 बन जाता है, that turns into OH. That's what's happening. So these are the conditions for this reaction. So we'll just quickly write the conditions. That's HCN plus NaCN is the catalyst. Achha, for reaction number 2, what is reaction number 2? A CN turns into a COH. I mean, this is what's happening in reaction number 2. The CN is turning into a carboxylic acid. So how does that happen? Will be यहाँ पे given है. That's a hydrolysis of nitriles. That if you have a CN, it turns into a carboxylic acid. Why? When you heat it with dilute acid, reflux, or dilute alkali and reflux. It could be any dilute acid or dilute alkali. We're going to use the dilute acid because alkali के अंदर issue ये कि it will end up forming a salt of the carboxylic acid. तो ये वाला जो है, that's dilute H2SO4 or HCl plus reflux. The CN turns into carboxylic acid. So let's move over here. This is reaction number 3. So in reaction number 3, you would notice that there's an alcohol and that turns into a ketone. बाकी चीजों को कुछ नहीं होता. CH3 remains there, and sorry, AB. So there's a primary alcohol which turns into a carboxylic acid, and there's a secondary alcohol. This one is a secondary alcohol because the OH is bonded to a carbon that's bonded to 2 carbon chains. So this one, मतलब अगर वो चार्ट में भी देख लो तो primary alcohols, they turn into aldehydes and then they turn into carboxylic acid through oxidation. Secondary alcohols, they turn into ketones. So in this case, both things are happening. So conditions क्या होंगे? That's going to be K2Cr2O7 acidified and reflux. और फिर क्या हो रहा है कि वो जो कीटोन है ना, वो वापस अल्कोहल में कन्वर्ट हो रहा है, यानी वापस भी हो रहा है. So but the carboxylic acid is not turning back, so the ketone is getting reduced as well. So this is oxidation, and now in the next part the ketone is turning back into an alcohol, a secondary alcohol. So that is the reverse, it's reduction. So how does reduction happen? NaBH4 says, like, if you form the ketone, you can turn back and turn it back into an alcohol. So वो वापस alcohol बन जाता है. So that's with NaBH4. I'm not going to use LiAlH4 because LiAlH4 से ना carboxylic acid भी वापस चला जाता है alcohol में. तो इस question में, in this specific question, the carboxylic acid wasn't turning back. It wasn't getting reduced. The ketone was. So I'm just going to use NaBH4, not LiLH4, ठीक है? Although to reduce a ketone, you can do that, but you're not going to use LiLH4. उससे carboxylic acid भी वापस उसमें convert हो जाएगा. तो ये बाकी तो वही होगा सब कुछ, जिसमें identify the role of NaBH4, so that's a reducing agent, ठीक है? What is meant by the term chiral center? It's a carbon atom which is sp3 hybridized, and it's bonded to 4 different groups. Four different groups. Okay, that's what chiral center is. It will form 2 optical isomers when there is a chiral center. अच्छा ये वाला. A reaction scheme is involved. This reaction 1. Now this is a cyclic alkane. मतलब carbon और बाकी हर carbon के साथ there's going to be 2 H's. So that's a cyclic alkane. ठीक है, state the essential conditions required for. So this is an alkane, and that. तो ठीक है, मैं इसकी बाकी की रिकॉर्डिंग भेज देता हूँ, ठीक है? या फिर कल हम इधर से कंटिन्यू कर लेते हैं. क्वेश्चन नंबर 4 से ना we'll continue tomorrow, ठीक है? आप लोगों की क्लास है, तो ये फिर कल हम क्वेश्चन नंबर 4 से स्टार्ट कर लेते हैं और थोड़ा सा जल्दी कर लेंगे. चलिए, ओके एवरीवन. और अगर कोई क्वेश्चंस प्रॉब्लम्स वगैरह हैं तो वो भी पूछ लेना, ठीक है। ओके, अल्लाह हाफिज।